the first step in working with the angling of the bounce enemy is we need to make an angle variable. So I'm going to type here private float angle. Okay, this is going to be what we are going to use. Now we need to use that angle to work on, well, how it's going to move. So to make a test, we're going to set this angle to 45 degrees. Okay, you might be familiar with this number because we might use Euler angles. So Euler angles work like this. They're very simple. Imagine we are here. If we move to the right, that would be 0 degrees. If we moved like this, it would be 90 degrees. Then we have 180, 270, and 360 again, or 0. So we have 360 degrees that we can use to move. Okay, so between 0 and 90 is 45. So the bouncing enemy should move like this. And how do we perform this operation? Okay, if we consider that the angle is going to store an Euler angle, we need to make a conversion here in the update method. So what we're going to do, let's ignore the moving left variable for now. Okay, let's just simply remove it. We need to perform a trigonometry operator to convert this angle into something that can make this velocity make sense. So what I'm going to type in here is going to be mathf.cos for the cosine operation. Between parentheses I have to type the angle, so I type angle. But the trick here is the angle is in Euler angles. It's in degrees, between 0 and 360. But whenever you use trigonometry operations like cosine or sine, the variable that is passed here needs to be in radians. It's a different format. So to convert to degrees, from degrees to radius, you can just multiply that by mathf.dag to rad, degrees to radians. Okay, so we're going to have the cosine operation. And the good thing about this cosine operation is that we're going to get a value between -1 and 1. So what we can do is we can multiply that by speed. And this is going to scale the value in the horizontal axis properly. We're going to do something very similar in the z-axis. So we're going to type mathf.cos, and here we're going to type angle, and we're going to multiply by mathf.dag to rad. But in this case, instead of cos, we're going to use sin for the sine operation. And we're going to multiply this by speed. Now we're going to save this. Let's go to Unity, wait for the compilation to complete. And now that this is done, if we press the play button, like this, you're going to see that it's moving in 45 degrees. In this case, the enemy was spawned in the right, and well, it's random. We don't know if it's going to spawn in the right or in the left. But, well, if you look at the scene window, it's moving like this, okay, with 45 degrees angle. If you set that to be another value, like 90, it would move up. So we can come here and change this angle from 45 to 90. And if we save this and go to Unity and try that again, then the bouncing enemy should simply move up. Okay, now we press play and it's moving up. So this is very important because now we can play with the angle variable and make the enemy to change its angle depending where it's hitting. So for instance, we can go here to the rolling enemy, and we can grab some of the code that we did. Okay, we have this here. Okay, we have this check for the direction change. So what we're going to do is, let's copy this, and we're going to the bouncing enemy, and in the update method we're going to paste it like this. But let's make things simple. I'm going to delete this complex if block that we made, and we're going to try just one situation here. We have if moving left and the position is lesser than a minus horizontal range. So we want to go ahead and write all of the cases. Now we're going to type else if not moving left and transform.position.x is greater than horizontal range. If this is the case, then we're going to do something. Now in another block we're going to type here if moving up and transform.position.z is greater than depth range, then we're going to do something here. Else if not moving up and transform.position.z is lesser than depth range, then that means we're going to do something else. And here is where the trick is going to happen. Okay, when this happens, we're going to change the value stored in moving left or in moving up, and then we're going to change the angle that we are working on. Okay, so here we're going to type not moving left, actually moving left equals to not moving left. And here we're going to type the same thing. Okay, moving left equals to not moving left. Here, moving up equals to not moving up. So we change the value that's set here, and we do the same thing in this spot. And now what we have to do is we have to think of what is the mathematics that we're going to work to make the enemy to bounce somewhere. Let's work on this in the next video.